Hello, welcome to the Lionhearted Academy. My name is Richard Tai. Welcome to today's lesson. Today is Trigonometry lesson 3, measure of angles. In the last lesson, we talked about what is an angle and how we are going to define an angle. So today, we are going to talk about the measure of an angle. So, the measure of angle is determined by the amount of rotation from initial side to the terminal side. If you remember from last time our lesson, we talked about in the standard position, our initial side should always be on the x-axis, on the positive x-axis. So you see I draw a blue line that indicating blue line segment on the positive x-axis, indicating that is our initial side. And so starting from the initial side, okay, this is my initial side, I can rotate. Now remember, if we rotate in counterclockwise direction, that's going to give us what kind of measurement? It's going to give us positive measurement. If I rotate clockwise, it will give us negative measurements. Okay, now from when we rotate in the counterclockwise, the amount of rotation will determine the measure of that angle. So when we draw the angle like this, let's label it with a Greek alphabet theta. Okay, so this angle theta has this amount of rotation from this initial side to the terminal side. This is the initial side, and let's go ahead and write the initial side, and this is the terminal side. Okay, so just like last week, and this is the vertex of the angle. Okay, all right, so how do we determine the amount of measurements? How do we determine, the amount of rotation? The measure of the angle is determined by the amount of rotations. Amount of rotations from the initial side to the terminal side. Alright, so how do we determine that? Now, there are several systems of measuring an angle. One of the most common ones is, of course, called the degree. Okay, degrees. Okay, and in a degree measurement, what happens is that we divide one full revolution into 360 equal parts. 360 equal parts. And each part is called a degree. Now, let me demonstrate to you what is a one full revolution. So let's suppose we start from the x again. Okay, let's say we start from the initial side. Okay, not quite get it. Okay, right here. So if I rotate in any direction and I come back to the same initial position, that's one full rotation. So again, that's one full rotation, and I can have one full rotation in the other direction as well. So in one full rotation, basically you're creating a circle. If you follow the track, if you trace the outside of the rotation there, you trace the arc, that's one whole circle. You divide that one full revolution into 360 equal parts, and each part is a degree. Now, the ancient Babylonians, they devised this system, and because they use a hexadecimal, which is a 60 base system, rather than number 10 base system, rather than a decimal system. They use a hexadecimal system, and so our 360 come from them. But also, it's very interesting that you notice that we have 365 days in a calendar year. However, in the ancient times, it actually was 360 days in most of the ancient calendars. So the 360 comes from that as well. Now, 1 degree, if you divide this into 360, this little circle right here, to do 1 degree is going to be very small. However, if we talk about physical objects as large as Earth, we actually have a degree is actually too large. So a degree symbol is a little circle here. So what we're going to do is, we divide 1 degree into 60 minutes. So 1 degree is further divided into 60 minutes, and 1 minute is further divided into 60 seconds. Now, the minutes and seconds are not exactly the same as our time, minutes and seconds, but they are definitely related. They're definitely related. So, later on, we're going to be talking about again. So, 1 degree has 60 minutes, and 1 minute has 60 seconds. But 1 degree is 1 out of 360, or 1/360th of a revolution. And 1 minute is 60th of a degree, and then 1 second is 60th of a second of a minute. Okay, so later on we're going to be using a lot. The degree and the minutes and the seconds is very useful in GPS systems, in locations when we're talking about places as large as our Earth. When we want to pinpoint a specific location, using degrees on the longitude and latitude is not precise enough. So we need to have minutes and we need to have seconds, and even units less, even smaller than seconds, like 60 point something seconds and things like that. So one way you can see how this written is probably maybe like 32 degrees, 24 minutes, and then 42 seconds. Okay, something like that will represent a certain longitude and latitude position. Okay, so degree is definitely one thing that we're going to use, and I think most of you are familiar with degrees, but let's just go ahead and review that one more time. Usually we start with 0 degrees on the positive x-axis. So 1 full revolution coming back to the same axis would be 360 degrees. So half of a revolution, that means when we rotate half a semicircle and half a revolution, it will be 180, half of 360. And a quarter of that, okay, which would be a 90-degree angle. So that's why 90 degrees forms a right angle. It looks like that. It's a quarter of the revolution. So that's 1 quarter, 2 quarters, 3 quarters. So down here in the bottom is 270 degrees. That's 3/4 of a revolution. And then, of course, when coming back, a full revolution would be 360 degrees. So again, going counterclockwise is the positive angle. Going clockwise is the negative angle. All right. So, but what's another system that we will need to use to measure angles? The other system, which is very common in science and math, is called radian. Okay, what exactly is a radian? Well, let's go ahead and take a look at. Let me try to show you what is a radian by looking at the diagram here. So we're going to look at the diagram of a circle. Let's look at this circle here. Now, the most important thing of a circle is the center and the radius. If we know the center, we know the radius, we can define the circle. So let's say this is the center, okay, and the radius is the distance from the center to the circle. So in this case, it's going to be this distance, r. Let's call that r. Okay. Right here, r. Okay. All right. So now imagine we're going to create an angle rotating r along the path of the circle. Now, as you can see, as I'm rotating r, I'm also traveling along the arc of the circle, which is this highlighted distance. I highlighted the arc, and usually we call this piece of arc, well, let's call that s, and so this is r. And so as you can see, as I rotate in a positive direction, as I rotate this direction, in the positive direction, okay, as I rotate, I created an angle. Let's call that angle theta. So radian measured, very simply speaking, how do I divide the radian measure is the arc length that's being traveled, okay, being rotated, divided by the radius of the circle. Now, so mathematically, let me give you a more precise definition, okay? So 1 radian is the measure of a central angle theta excuse me, that intercepts an arc S equal in length to the radius of the circle. Alright, so let me give you a more simplified version of this. What it's basically saying is the measurement of radian theta is simply the measurement of length arc divided by the radius. So when you rotate on this circle, it doesn't matter how large or how small the circle is, you are going to travel a certain arc as according to the amount of rotation. You're going to travel a certain length from this point to this point. Okay, from point A, let's call this point A to point B. Right? You're going to travel through the arc S, and let's call this point O as for center, for origin. So this arc length S divided by the radius R, that ratio is going to be the amount of rotation in radian. So theta is going to be S divided by R. So you can see if S is equal to R, okay, so if S is equal to R, then the theta radian is going to be S divided by R is the same. It's going to be 1 radian. 1. Now, radian has no units. Radian has no unit because S and R, they're measuring the same unit of length. S can be feet, R can be feet, S can be meter, R can be meter. So S divided by R is going to be a unitless measure. So radian has no measure. Alright? Well, so let's go ahead and take a look at a little bit more on the radian. So how many radians we have in a circle, in a full revolution? Well, let's take a look at this. So, let me draw a circle here very quickly. Okay. Now, normally, okay, we start with R, right? We start with R in the middle. So if I don't have any rotation, I start with 0 radian. Okay, this is 0 radian. Notice I didn't put any circle sign next to it. Okay, so it's about here. That would be approximately 1 radian. Okay, because that piece of arc, that's exactly approximately the same distance of the radius. That would be approximately 2 radian. This would be approximately 3 radian. 4 radian, approximately 4, approximately 5, and approximately 6 radian. So 2 radian, 3 radian, 4 radian, 5 radian, and 6 radian. So I'm giving you an approximate conceptual understanding to see where the radians fall. 1 radian falls here, 2 and 3 radian approximately falls there, 4 and 5 and 6 radian approximately falls there. Okay, so as you can see, a full revolution doesn't coincide with any integer number of radians. But let's think about this. What is the arc length if we travel the full circle? Well, if we travel the full circle, if we rotate the whole circle, okay, like if I highlight this whole circle, what is that distance called? If you recall from geometry, that is called the circumference. Okay, excuse me. It's called the circumference. And the circumference of the circle is 2 pi times the radius of the circle. Okay, times the radius of the circle. So if my arc length in a whole revolution is 2 pi r, okay, so in one revolution, in one full revolution, my arc length is equal to 2 pi r, then that means my radian measure was going to be S equal to R divided by R, which is 2 pi R divided by R. And as you can see, the R cancels out, so theta simply become 2 pi. So in one full revolution, you have theta equal to 2 pi radian. This is the radian measure. And that's where we get the 2 pi from. So this will allow us to convert easily between degree and radian, and also understand the radian measure in terms of how many revolution we have. Okay, so let's go ahead and take a look at some very easy examples here. So before we start revolution, we have 0 radian. Okay, after we complete the whole revolution, we have 2 pi radian. So that means half of the revolution from the initial side here, from positive x to negative x, is half a revolution, which is pi radian. And half of the half revolution is half of 1/2 is a fourth. So it's pi divided by 4. Okay, so this is pi divided by 4. This is pi over 4 revolution. And this is also pi over 4 revolution, right? Every 90 degrees is pi over 4 revolution. Every quarter is pi over 4 revolution. So down here, this is 3 pi over 2 radian. Okay, every quarter revolution is pi over 4. Quarter revolution is pi over 4 radian. Okay, so that's the basic understanding of where the major angles are. And this will give us an equation that will allow us to convert between degree and radian, which is something that we definitely will talk about next week. But let me just go ahead and do this very quickly. So a degree, how do I convert a degree to radian? Well, a degree is a radian because, as you can see, in a full revolution, right? Let me go ahead and write this. In a full revolution, theta is equal to 2 pi, but theta is also equal to 360 degrees in a full revolution. So that means the degree equivalent to radian would be always followed by this ratio of 360 degrees equal to 2 pi radian. And if you reduce it by 2, we can have 180 degrees equal to pi radian. So that is the conversion ratio. That is the conversion ratio that we will always be using. So you need to remember 180 degrees is equal to pi radian. Okay? Alright, so I think we will stop here today, and then hope you enjoy the lesson, and then please leave any questions or comments you have on the comment section, and please don't forget to subscribe as well. Next week, next lesson, we'll go ahead and take a look at how to convert degree and radian. We're going to do some examples, and then hopefully we'll go ahead and have more trigonometries from here. Thank you.